Okay, we are looking at improper integrals in this video, and we're going to look at a case that ends up being divergent. So I'm giving you the answer right up front. I'm telling you that this is going to be divergent, and we're going to show that it's divergent, and then you'll see what it means for it to be divergent. So we're looking at this one, and I have another video on improper integrals right before this one in the list, what we did there was we said, okay, well, if we're using infinity as one of our limits, okay, this is what makes this improper. Because for the fundamental theorem of calculus and really for integration, a definite integral should have a finite interval that you're looking at. And in this case, it is not finite, it's infinite, because if you see here, it goes from negative infinity to e. So what we're going to do is we're going to take the approach of a limit. And we're going to say the limit as n goes to negative infinity. And we adjust the limits of integration to represent now that we're going from n to e. And we still stay with the same function, 2e to the minus x dx. And what we're going to do is we are going to integrate this the way that we know how. And this one is a very basic integration using u substitution. So I'm going to write integrate by a u sub. All right, integrate by a u sub. So let's go ahead and figure out here what u is. Well, u is going to be minus x. And du is just going to be a negative 1 dx. So we've got the dx in play. We just need to make the negative 1 happen. We can write that there. And I'm actually not going to put negative 1 because then it looks like a 12. I'm just going to put a negative. And I'll put a negative on the outside to compensate because you have to balance it out. It has to stay equal to 1. So let's say that this right here is our u. And this right here is du. Okay, so we have a negative and then we've got a u, right? Du, all right, and that's what we're going to integrate. So let's just do that little work here off to the side. And let's say we have the negative integral and we've got 2 e to the u du. So that just works out to be a negative 2 e to the u plus c. All right, really nothing to it. And so we're going to come back and we're going to say, well, that's just negative 2 e to the minus x plus c. Of course, this is the indefinite integral case. We're going to use this result right here for our actual integral that we are working with. So we take this to be the limit as n goes to a negative infinity. And we know that the result of the integral there is going to be a negative 2 e to the minus x. All right, and we're going to evaluate this from n to e, And now we just simply have to plug in negative 2e to the minus e minus a negative 2e minus a negative 2 e to the negative n. Okay, so really there's nothing to it. This becomes a plus. All right, this right here is some number, okay? Some constant number, e to the power negative e, that's okay. But what interests me here is this right here, is the fact that n goes to infinity. So you have e to a negative infinity power, all right? And it's negative times negative, so this really becomes e to the positive infinity, if you will, okay, when you think about it. And that makes the difference here. Because you have a negative times a negative infinity makes it positive infinity. That means that this right here all together is just going to go to infinity. So it really doesn't matter what this is, all right? Because you're just tacking it onto infinity and it's going to be approaching infinity, all right? Therefore, what we can draw, the conclusion we can draw here is that this right here diverges. All right, this diverges. Why? Because it doesn't seem to settle on any particular number. So this is the case, again, of an improper integral where it can diverge. You're going to see in the previous video that I made about improper integrals that, you know, they can converge to a particular number. All right, but in this case, this one is one that we say is divergent. All right, so as always, I hope this video is helpful. And remember, like and subscribe.